The other one, we're changing out the hardware, so there'll be no changes to my SCADA system. My visualization will stay the same. If you look at the picture, you can't see, but you'll see on this picture here, if you come closer, that there's some Chinese and some English. So when you do the upgrade, you may say, well, we don't actually want to see the Chinese on the screen. That was for the Chinese that came and did the commissioning when we originally built the plant. So remove the Chinese, which is the smallest of the problems, because what we actually find is that on the SCADA side, because you're changing the naming convention in the PLC, your SCADA will change. You'll need to change the naming in the SCADA. You'll need to change the naming in your IO server, because the naming convention has changed. Your PLC addressing has changed. Your communication protocols and your communication hardware has changed. And then you'll find during commissioning that, when they did the initial commissioning of this plant, after they've sent the PLC guy home, there was some additional control that had to be done. So we scripted that into the SCADA. We didn't tell anybody, but we scripted it into the SCADA. So when you upgrade your control system and it's not part of your control philosophy, when you put in your new SCADA, then you don't put in that script, because control does not belong in the SCADA. Control belongs in the PLC. And then the plant doesn't work. And then you have to go back to the SCADA and go and investigate and kind of analyze all the scripts to see what has changed. And then you'll also find that in your SCADA system, because they had a different, when they commissioned the plant, the instrument that they had in the field sent the information directly into the PLC, and the PLC did the scaling, but they've changed the actual equipment or the actual meter 5 years ago, and at the time when they did that, there was no PLC guy available to make the change. So now, but there was a SCADA guy. So the SCADA guy used the PLC code and changed the ratios, right, to actually make the instrument accurate or display accurately in the SCADA system. Those are the type of things you only find out when you're commissioning on site. Right? Lots of sleepless nights just to find out, that's why we're not getting the correct signals in, because in the SCADA we're actually dividing it by 1,000. And did we mention that some of the comments in the PLC is in Chinese? Or all the comments in the PLC is in Chinese? This is another one that has bitten us a few times. No inter-PLC communication. We don't have inter-PLC communication. All communication go from the PLC into SCADA. There's nothing until you get to site and you start commissioning and you find that something's not working. So we're creating the recipe and we're sending it through to the SCADA, or we're creating the recipe in the SCADA and we're reading it with the PLC, but nothing happens. And then they say, okay, yes, we had a problem with the number of I/O available on this PLC. So we did this little recipe management thing in that PLC. Sorry, we forgot to tell you when you actually did the original design that we actually do have inter-PLC communication, which is something you don't want to hear when you're sitting in the plant at 1 o'clock in the morning. And then the other part is, but in addition to that, that PLC is on a different communication protocol than this PLC. So we don't have inter-PLC communication via the same communication protocol or hardware. So we're not talking Profibus to Profibus or Profinet to Profinet. We're getting the information from the PLC, we're putting it into our I/O server and transferring it through the I/O server into the other PLC. So instead of doing it the right way, we do it in a let's make it work way. So those are all the issues that we find, not all of them, some of the highlights, the issues we find when we do control system upgrades. Now, how do you ensure that you don't step in it when you're actually doing it? When you're planning a project like this, these are the things that's going to hurt you. How do you prevent that pain? How do you make sure that you plan properly for these things? Firstly, define the battery limits. What precisely are we doing, and what is our responsibility, and what is the responsibility of the end client, the plant manager, or the automation department? Where do we start and where do we stop? You have to have an approved control philosophy. When they tell you that the code is in the PLC and the visualization is in the SCADA, and that will show you how the plant is controlled, don't accept that. Because even if you do that, you can rewrite line for line, and they will still tell you that the plant doesn't operate like this. You have to make changes. So get the control philosophy defined up front so that you're sure that you have the correct control philosophy. That will save you nights and nights of pain. Then define the PLC and SCADA standards with your functional design specification. So what standards are we going to use? We are going to use these types of blocks. We're going to use this type of control to satisfy our control philosophy. Then, and this is an important one, audit and define inter-PLC communication. So go and look at the PLC and in the SCADA if there's missing parts that potentially live somewhere else. Right? It's not that easy to do, but it is something that needs to be done. You have to actually make a conscious effort to look for those, because I can almost guarantee you will find them. Then the same thing about field instrumentation. If you don't know a proxy has been bypassed in the field and you actually note it down before you start your project planning, then when the time comes and that proxy does not work as it should, it will become your problem. So you have to find it before you start the project so that it does not become your problem. Okay? The same with the field panels. You saw the state of some of those field panels that I displayed previously. Audit them, see what's in there, even if you're not going to replace them, because you may need to communicate to those. And then you'll find these controllers that is supposed to be a variable speed drive, but actually works with a little toggle switch, right? Or a little knob. You don't want that. You don't want to find that out when you're doing commissioning. Then also audit when you get to site, or actually when you get to commissioning. You need to audit your switchgear, your contactors, and your auxiliaries. Because between the time that you were there 3 months ago when they switched off the plant and the day you get there, that will change, because they're going to come and pirate auxiliaries. They're going to come and pirate contactors because they're too lazy to go to the store to draw some. Also audit the equipment state. Because if a piece of equipment is not working when you start your project and you don't define that and you don't put that into battery limits, when commissioning comes, it will be your problem. You will have to get it to work. Even though it hasn't worked for the past 5 years, you'll have to get it to work. We had one of our clients, there's some amp readings on the SCADA. And the amp readings are not showing. So we had to trace from the SCADA to the PLC to the actual instrument, and then we get to the actual equipment and there's no CTs. So there is no field instruments, but it worked 3 months ago. Right? They all worked. And then we actually went back and we looked at 2 years ago, we did a site visit and we took a picture of the SCADA system. And last year we went back and took a picture of the SCADA system. And in both instances, those amps did not show on the SCADA. However, we had to fix it. They went, put in CTs, and we had to make it work. It became our problem because we did not identify that before we started the project and before we started commissioning on site. PLC connections also ensure that the PLC connections are all sound, comms are happening between them. SCADA scripts. Now that's an interesting thing because people don't necessarily think that or assume that control will be done in the SCADA because it is not best practice and it is not standard. However, you will find that there's stuff in the SCADA that directly controls the plant. So you need to go and identify and find out those scripts. Go through each one of the pages. See how they work. See how the animation works. See how the control and the comms work. Make sure that there's no scripts in there that will basically be a hurdle when you do commission. I think I've already talked about the communication. Ensure that when we talk from one PLC to the next PLC, we go through a proper communication channel, not via an I/O server. Okay? And then the final one, spend time in the running plant. Take some videos. Take some notes to make sure that what you deliver is what is currently in the plant. Because remember, we're only duplicating what we have now. And everything is working. So when you're looking at the SCADA and there's a lot of red equipment and they say, well, don't worry about that. It's actually running. It's just the sensor that tells me the running signal is not coming back, but we know it's running. When you touch it, you own it. You have to make sure that the instrument that tells it that it's running gets fixed. At your cost, potentially, right? But definitely at your time, because it will become your problem. And that concludes my presentation. Is there any questions?
Have you ever made a profit on a project?
Yes, we have made profit on projects because we look for these things, right? And that's the only way that on an upgrade project you can make profit. But we had to go through a tough learning process in a learning school to find these things. And this is not an example of one project, it's an example of a number of different projects. So you're not going to find everything, but it's better to tick the boxes so that you don't walk into a project like this with closed eyes and then stumble during commissioning. Because everything will be fine until you put the rubber on the road and then it will hit you like a snowball out of the blue. Any other questions?